Hello, everyone. How are you guys doing today? Good. I'm actually not feeling so well. Right. I think I'm going to get sick. Every semester, not every semester, every year I get sick when the from summer to winter comes or winter to summer comes. Every year. Winter, I get sick twice every year. Cool. Okay. Yeah. Okay, so instead of going through the lecture notes, I decided just to go over the review. So you're going to learn the materials, whatever we have on the review sheet. And once we are done with the exam, when we come back, I will hold one class to go over all the materials which that happening from chapter 10. For example, rationalize, we skip something from rationalize. And then if you think anything in the homework you cannot do, but you need my help, we'll go over those in class for those materials. Okay. Now, I decided to start our lecture from the end of the review sheet. Okay. So the last thing we have in the review sheet is reduce the power of I. So what is I? When we have square root of any negative number, it doesn't exist in real life. It doesn't exist because there is no number we can figure out when you multiply itself twice turns into -1. That's why it doesn't exist in the real life. But somehow mathematician says, well, it does exist in the imaginary world. We call it I. I means it's that real imaginary number. And whenever we have imaginary number in a number system, we call them complex number. Complex number means we have a real portion, so we have an imaginary portion in the real life. For example, 2 plus 3i. 2 is a real number. We know what is 2, but we have no idea what is 3i. So when you put together real and imaginary, both of them together, we call them complex. It's so complex, you have no idea what's going on. Okay. So the format for any complex number is a real number first, and then we add or subtract the imaginary portion. B is a real number, but I, we don't know what is I. Square root of -1. And we also know if you have I squared, what is I squared? -1. So you see, when we have square root of -1, it's I, but when we have I 2 powers, it's not imaginary anymore. It's real number -1. So anytime we have I with more than 1 power, we don't want that. Because sometimes the thing we have for I with the more than 1 power gives us a real number back. Sometimes it gives us just I back. So anytime we have I with any power that is more than 1, we must reduce the power. And when you reduce the power, reduce the power on I, we have 4 outcomes. Your answer must be from these 4 outcomes. The answer could be 1, real number 1, or it could be real number -1. Or you may get I or imaginary -I. So I with any power that is more than 1, we cannot leave it. We must reduce it and get one of these. Depending on the power, we get sometimes -1 as our answer. Sometimes we get +1 as our answer. Sometimes we get I as our answer. Sometimes we have -I as our answer. It all depends on the power on the I. What power we have on the I? Well, there is a trick. Actually, there is not one trick. There is so many tricks to figure out your answer. Which one of these is our answer? That one I came up with last night was kind of amazing. to me. Like, cool, why I didn't think about it before? I realized that if you have I with even power, then we have two scenarios. Okay? That power is divisible by 4. If you can divide by 4, the answer is 1. Okay? If I has any power that is divisible by 4, the answer is 1. But that power is not divisible by 4. Well, actually, I should write this way. It's not divisible by 4. Not. That means the answer is -1. Okay? But the power has to be even. If I has an even power, see if you can divide the power by 4. If you can, the answer is 1. If you cannot, the answer is negative. But if I has odd power, then break it down into 2 pieces. I with even power and a single I. Every odd number we can split into 2 pieces. One is even and one is a single line. For example, 3. We can break down 3 into 2 and 1, right? 37. We can break down into 36 and 1. So every number we can break down into an even number and a one single line. So for odd number, break them down. And when you break them down, you see even. So for even is this. Okay? So if it's divisible by 4, it's 1, but then we have an I next to that, so it's 1i. If that even power is not divisible by 4, that means it's -1. So it will be -1 times I, which is -1. Cool. Okay. So let's apply this knowledge into some question. I to the power 22. Can we divide 20 by 4? No. So what's the answer? -1. If you can remember these rules, you don't have to show any work. If you cannot remember the rules, you must show work. Okay, next one. I to the power 40. Can we divide 40 by 4? Yep, so what's the answer? 1. Cool, right? I was actually impressed on myself. Wow, how did you think about that? Let me show you a few more examples and then I'll show you what I usually teach or how I usually teach reducing the power of I. Let's say we have the next one, no problem. 23, but we have an extra power 3. Power rules. If you have more than one power, what do you do? Do you add? Do you multiply? Do you subtract? Do you divide? What do you do? Multiply. So first step, multiply them. What is 23 times 3? 69. 69 is an odd number, right? That means you have to split it into what? I to the 68 and a single I, right? Because the rule says in multiplication, we add the powers. So we split our 69 into 68 of together and one other single. So this single, our answer will be with I or -1. Now we are going to decide, is it I or is it -1? Which one is our answer? So we look at the 68. Can we divide 68 by 4? Let's see. 4 goes to 6 how many times? 1. 1. So 4 times 1 is 4. We subtract, we get 2. We bring down our next 8. Can we divide 28 by 4? 17, right? That means, yep, we can divide 68 by 4. So how much is this? 1. So the even portion gives us the number 1, but we still have our I left. So it is 1 times I, just I. So we have a multiplication here. We split our 69 into 2 pieces. One is the even number 68, and one is single I. Single I, we have nothing to do, we carry it down, but the even power, we have a rule for that. If the even power is divisible by 4, the answer is 1. If it's not divisible by 4, the answer is negative 1. So the even portion gives us 1, and we are multiplying our single I that we can calculate. Okay? How come I get so excited? Come on. I'm really excited about this. Because every time I teach this concept, most of the students get confused. Like, what's going on? Why is this? Why is that? I realize this is the easiest method I figured out so far. So is there anybody who's confused? Ask me, because I'm doing an experiment. This is a new method I learned. Not learned, I figured out. So I want to see how effective that is. So what do you think? Did you understand, guys? Is there anybody who did not understand? Because I want to see what you did not understand so that I can improve myself. So who did not understand this? Anyone?
A little bit, just the last bit, like 1 times I don't know what the side.
Did you understand we split it 16 and 2?
Yes. Yeah.
So what sign goes between them?
Multiple.
So this gives us 1, and then we have the multiplication in the middle, and then we have our I.
Okay.
So it's times. Let's do a few more. Let's say we have I to the 55. I to the 55, is it odd or even? Odd. That means you have to split into 2 pieces. Oops. I to the what? And times I to, so single I. Now 54, can we divide 54 by 4? 4 goes to 5 how many times? Once. And we get 4, subtract 1, we get 14. Can we divide 14 by 4? No. So it's not divisible. Since it's not divisible, then how much we get from here? Negative 1. So we have negative 1 from here, and then we have times the I. What is negative 1 times I? Negative I. Okay. Let's do another one. Let's say we have I to the 5 times 25. Big number. What is our step 1? We must apply our exponent rules. 2 powers together means multiply. So we get I to the what? 125. Is it odd or even? Add, right? 125. That means split. I to the what? 124. 124 times a single I. Can we divide 124 by 4? 4 goes to 12.
Yes.
3 times. 4 goes to 4. 1 time. So, yep, it is divisible by 4. Since we can divide our power by 4, what is this portion? How much is this? 1. And we have the times I. What is 1 times I? I.
Yeah.
The rule says if you can divide the number, the power by 4, then say 1. It's a rule. If you cannot, the answer is -1. No, we have four answers. Sometimes we get the answer as 1, sometimes we have -1. Sometimes we have I, sometimes we have -I. When we reduce the power of I, we must have answer one of these as our answer. We cannot have anything besides these four. Now we did first example I to the 22. We cannot divide 22 by 4. That means our answer is 91.
So if you can't divide it by 24, it's -1?
No, if you cannot divide the power by 4, then the answer is -1. But if you can divide the power by 4, the answer is +1.
And then,
For even power. Okay. See, here we have even power. Here we have even power. So we apply the rule directly.
what about how do you get the odds?
When you have odd powers, then the answer is either I or -I. So for example, here we have two powers together, we multiply, we get 59. 59 is odd. So we split into two pieces. One is even and one is a single line. Now this even power, we can divide by 4. That's why it turns into 1. So multiply 1 from here times the I, we get I.
So when you can't divide it by 4 for
The answer is -1. For example, this one, I to the 55.
Yeah.
Since it's odd, so it's split into two pieces. One is even and one is single I. Now this even power, we try to divide by 4, but it will not. 54 is not divisible by 4. That means that I with this power turns into -1. So -1 times I gives us -I.
so only when the I has an even power, that's
No, I is an even power. That power is divisible by 4.
oh well yeah, 1 is -1.
Mm-hmm.
And then when it's odd,
Odd power is split into two pieces.
the answer is supposed to be
I or -I. Cool, right? Okay, now let me show you how I usually teach this one. If you don't understand, no problem. For example, I to the 29. Well, 29 is two numbers, so it's split into two pieces, I to the 28 and I. This is different method, okay? Different methods. So what I used to said, well, divide this power by 2. When you do that, you get I squared with some power. I squared with what power gives us 28? 14. And we have a single I left. Well, why did you divide by 2? Because you already know what is I squared. What is I squared? I squared equals what? -1. You must know this, okay? Square root of -1 is I, but when you have I squared, it's a -1 real number. So you must know this because every time you see -I, we have to replace with -1. So this I squared turns into -1, and we have -1 14 times. So if you multiply -1 even times, what do you get? 101. So 1 times I, that gives us I. I don't know what's wrong with this explanation, but most students don't understand this. Please.
We could just do the old one.
So I told you like what's wrong with this? Why people don't understand this? So I actually taught this yesterday, my morning class, and everyone was like, what's going on with this and that? So I was thinking, before I teach you, can I use a different method? And I figured out a new method. I'm really excited actually. That's why I started my lecture with this one, with this topic. So I will share the lecture link from my morning class with you guys. So if you find this explanation is easier, stick with this. But definitely I will say this is much easier. If you found the first method is much easier, stick with the first method. Or if you already know other methods from your previous classes, feel free to use it. As long as you show me your work, I'll give you credit. But if you do it mentally without showing work, sorry, no credit. Okay? And I'll ask a few of these in the exam. Actually, there was one question in the final exam. It was 2835. I to the 28 plus I to the 35. So in the final exam, they had something like this. Do the simplifying thing twice because you have two i's. Good thing one of them is even. So you don't have to work hard for here. 28. Can you divide 28 by 4? Yes. So from here, what do you get? When you can divide by 4, the answer is? I is 0. When you can divide your power by 4, what's the answer? 1. It says I0. You don't have to write this down. You can simply write 1. But yes, it's I to the 0 and then I to the 28. But anyway, you don't have to do anything. If you know, if you show me this, I'll understand. Oh, you just divided by 4. I understand. But now this is add. So you have to split that. What do you get? I to the what? 34. 34 and a single I. Now if you observe this 34, can we divide 34 by 4? We can divide by 2, but we cannot divide by 4. So what do you get from this portion? -1. So we have -1 times the I. So how much you get from here? Negative I. But don't forget, we still have 1 in the front. So minus I. So you have plus and minus together, that turns into a minus. So we do the same thing, but twice. And then at the end, it is combined by result. Who is confused?
You said that I with power 2 equals to -1. Is there some other i's with any powers equals to the exact number?
You can remember I to the 4 is 1.
What?
I to the power 4 is 1. You don't have to, but if you want to remember, you can always remember I to the power 4 is 1.
That's it, only these two there.
That's why if you can divide by 4, the answer is 1. You may wonder why. So let me show you real quick why. I to the 28 is I to the 4. How many times? 7 times. But what is I to the 4? 1. So if you have 1 7 times, what is the answer? 1. See? That's why if you can divide your power by 4, the answer is 1. If you cannot divide the power by 4, that means it's divisible by 2. And 2 means -1. So the answer is -1. Any other question?
Optional.
I showed you 2 methods. Whatever is easier for you, you can use that. So now you try 160 and 71. Let me get a paper. I to the power 60 minus I to the power 71. I would like to give at least 2 of these in the exam because you have 4 scenarios. So 2 i's here, 2 i's in the other one. I'll have 4 scenarios together. And if you're done, you can try another one. I to the 71 minus I to the 60. What happens if you switch their sign? Ready? Dunhill, would you like to try the first one?
Yeah, 1 minus 5.
So 60, can you divide 60 by 4?
Oh, yeah.
We can write 4 goes to 60 how many times? 15 times. So it is divisible. That's why this is 1. And I to the what? You split 71 in 2?
Then 71 divided by 4. Get 17 divided by 3. 3 will be I.
3 is negative I.
3 into the remainder.
3 is negative I, not I. So 70 and I to the 1, single one. And now I to the 70. Can you divide 70 by 4? No. That means, what is this? So we have negative 1 times I, and we have 1 here. So what is our final answer?
1 plus.
1 plus I. But you got 1 minus I, right? The mistake?
That's
Sure, go ahead.
I and I.
Then
Negative I. 1.
negative 1, and then I
1.
minus 1. So what is our final answer? Negative 1 times I
1.
times I. What do you have?
Negative 1.
Negative I. So negative I minus 1.
I'm thinking here we can make 1 and
We cannot
not.
multiply to which one? The other negative 1? Negative 1 times I, that gives us?
No, the last answer. I just wanted to remove the next to the I. And I wanted to move on to negative 1.
You mean you want to take out negative as a common factor, you get I plus 1?
It's not.
So you're not multiplying. You can pull out as a common factor, but you cannot multiply. Remember, in order to multiply anything, we have to have 2 sides of an equal sign. But here we don't even have an equal sign. Okay. So whatever is easier, as long as it's correct. Okay. So you did correctly, but then you have to remember I squared, I cube is I squared times I. What is I squared? Negative 1. So negative 1 times I, negative 1. Many people has many methods, okay? Sometimes when I hear different methods, they are cool, but you have to remember lots of things. So you can find them anytime you bump into any other methods, no problem. As long as it's easier for you, stick with that, but must show your work. How did you figure that out? Okay. So any question on reducing the power on I? No. Now let's do dividing I. Bad news, we don't know how to divide by I. Why? Because I is square root of something. And we don't know how to divide by any type of radical. So instead of divide, we use a method, it's called conjugate. Do you remember what is conjugate? Yeah. Let's say I have x plus y. What is its conjugate?
1.
Perfect. And what happens when you multiply to conjugates? What do you get?
The middle one is
Right. So the first one square minus the second one square. So when you multiply, we get difference of perfect squares. That's why anytime we rationalize denominator or numerator, or we want to divide by I, we apply conjugates. Conjugate makes I disappear because you're squaring them at the end. So first question says 1 minus 6i divided by 3 minus 2i. Well, we don't know how to divide. So instead of division, we do rationalization. In rationalization, we multiply top and bottom by same thing, right? And here we are going to multiply top and bottom by the conjugate of the denominator. So what would be the conjugate of the denominator?
3 plus 2i.
3 plus 2i. Our goal is to get rid of this I from the denominator because I is square root. We don't want to have square root on the bottom. So we are happy with 3, we are happy with 2, but we are unhappy with I. What can we do so that I gets here? Well, mathematicians are so smart they figure out, well, just multiply by conjugate. The I will disappear. So in the denominator, we get, if we apply the difference of perfect squares, what do you get?
4i squared.
Good job. The first one is 3 squared, and then we have 2i squared. That gives us 9 minus 4i squared. It's 4i squared because you have to distribute the power on everything inside a parenthesis. But remember I said, anytime you see I squared, you cannot leave it alone. What is I squared? -1. So we get 9 minus 4 times the -1. That becomes what? +4, which is 13, right? See, denominator doesn't have any I at the end. So you're happy with the denominator. We don't care about the numerator, okay? We can have as many i's as you want, no problem. So in the numerator, we distribute them. So we use FOIL. 1 times 3, 1 times 2i. So 3 plus 2i. And then the other way around, let me pick this blue. -6 times 3, what do we have? -6i times 3. -18i. And then -6i times +2i.
-12i squared.
We have another I squared.
So we can put as -1.
We must put it as a -1. And if you observe, we actually have like terms here, right? So we have 3. And what is +2i minus 89? Perfect, -69. And we have -12 times that -1. That gives us +12. In other words, every time we have the term I squared, it changes its sign. So we have -12i squared. That means it's +12. Do we have any more like terms to combine? We have 3 and 12. How much again?
15.
So 15 minus 16i. 15 minus, well, make sure right on the top. 15 minus 16i over 9 plus 4. 15 minus 16i over 13. And this is a complex number because you have real and imaginary together. So we want to separate them. We want to see which part is the real number and which part is the imaginary number. So we split our numerator into 2 pieces. We write 15 over 13, that is the real, and we have 16i over 13, that is the imaginary portion. So any complex number, we should write this way. This is the format, like the format of writing our name is first name and last name, right? Or on official paper, it's last name, comma, first name, right? Same thing, how do you write? This is the format of complex number. How do you write them? It's the real number with the denominator, and then plus minus the I portion with the denominator. Any question?
So the last answer will be the correct last answer will be that one. Which is
The box one.
And we cannot simplify the numerators.
15 and 13, they are not divisible by anything.
But if
it's divisible, we simplify. Okay, you try the next one. We have 3 minus 4i and 5 plus 6i. And these are final exam questions. One of them will definitely see in the final exam, as well as in your exam on Tuesday. So let me take that to the next one. So today is 9 what? 17. Angel is here, Stephanie is here, Krishnali here, Mary Elvis, sorry, here,
What a dog.
Chris here, huh?
What a dog.
So that we can get rid of the I from the denominator. Cassandra here. Angie here. Parker, no phone. Tenzin, Yaribel, Neva absent. Julia here. Gavin here. Gerald, I thought I saw him, not here. Vansh here. Yvette here. Ryan here. How come you guys change your seats? Daniel is there. You guys switch your seats. Christian here. Ayan. Joel here. Janelle here. Dunhill here. Cole here. Isabella. Dua absent. Nazima here. Zihong here. Matthew here. Chris with K. Nope. Cindy here. Melanie here. Tony here. Shri absent. Jocelyn and Jessica. Are you guys done? Almost done? Vansh, what do you multiply top and bottom by?
5 minus 6i.
Wonderful. 5 minus 6i. So what do you get on the denominator?
5
Mm-hmm.
minus
6i squared, which becomes?
5.
Mm-hmm.
36.
Negative 36i squared. And what is negative 36i squared turns into? Because this is -1, right?
Yeah, so when it
Positive 36. And how much is 25 plus 36? 61. Great. Cindy, would you like to try the numerator? So you have 15, and then 3 times negative 6i, negative 89. Then you go other way around. Negative 4 times 5, minus 20i, positive 24i squared. But I squared is negative 1. So the 24 becomes what? Negative 24. And we have 15 on the front. And what happens in the middle? Negative 38i. Negative 9 minus 38i. Negative 9 minus 38i. Whole question?
If the I switch on to a -1, then how is it still positive 36?
Because originally it's that. So negative 36 times negative 1. But we should not keep this. So what do we write? Negative 9 over 69 minus 38i over 69. Great. Chris, any part of confusing?
I just got it wrong on the, but it's all right.
In math, right? Not in the steps?
Yeah, so I put down, with the plus 24 I squared, I kept it as plus and then it became negative. Not in this one.
True. Because anytime we have I squared, the term will change its sign. So 24 is plus here because we have negative I, so because we have I squared, so that's into negative 24 in the next line.
Because it's 24
Times
Negative
negative I, negative 1. Okay, that's how we divide imaginary number, which is actually not a division, it's called rationalization. So you rationalize denominator for I and also rationalize the denominator for any type of root, any type of radical. In here, we actually did two things. We learned multiplication, which is on the top, and we learned double division. Okay.
Go back for a second.
Yeah. So anytime you multiply imaginary numbers into the same thing, you spoil, then I square turns into real number. You combine the real numbers.
So you separate the fraction again.
And sometimes when you separate them, then it's divisible. I mean, it's simplificable. You can simplify, do that. If you cannot, then you don't. Cindy.
The final answer is negative 35 minus 30.
We have to have a sign right in the middle. So I prefer to use the sign in the middle instead of sign on the front. So you can write this as negative I over 61 plus negative 38 I over 61. But why wasting your energy writing the sign twice? Because at the end, when you multiply, it turns into negative anyway. But they both are same. The paper here. Now, one more question from the multiplication. This is the question. 5 and 2i. Square root of 5 plus 2i. Square root of 5 minus 2i. Do you see something here? What do you notice?
The in the middle, there's 2i squared 5, which has
So we actually have conjugates here. We have the exact same 2 times square root of 5 and 2i, just their middle signs are different. So we don't have to use FOIL. Yes, you could definitely use FOIL, but you don't have to. You can simply take your first term and your last term and square them. So our first term is square root of 5, second term is 2i. Whenever we multiply any conjugates, we get the same thing. The first one squared minus the second one squared. What is square root of 5 squared? 5, because they cancel out. And what is 2i whole thing squared? 4i squared. Common mistake, people think it's 2i squared. It is wrong. It's 4i squared. But what is I squared? -1. So the -4 turns into a +4 because we are multiplying these. -4 times -1. So what is our final answer? 9. You see, they gave us 2 imaginary numbers, imaginary binary to work with, but we realized they actually gave us the number 9 in a fancy way. We can actually set our password for anything fancy way. The number should be easy, but only a mathematician can able to figure this out. Or anybody who knows math. For example, 9. We may have our password 9999, and this is our hint. We can put, let's say we have 9 3 times, okay? Just a joke, okay? Let's say we have 9 3 times. Our password 999. Well, we can say this is our hint. So 999 3 times. My sister actually does that. She uses chemistry. Alpha, beta, gamma, water, alcohol, all these things as her hint. So I was like, what are you doing? She's like, well, this is my hint because whatever password she has, she can easily connect the numbers with chemistry. I was like, cool. I can connect my number with math, but not with chemistry. But she always does that. Her hint is H2O. So look, what is H2O? It was like it's something with H twice, and then we have some type of thing with O. So look, cool. H2O, water. Okay, so yeah, math is actually fun if you know what is going on. For example, here, just number 9. So weird way they gave us. Figure out it's number 9. Okay, so that's how we multiply i's, we divide i's, we simplify the i's. And there is one question, something like this one. Negative square root of 36 plus 2 times negative square root of 49 minus 100. Simplify. We have to simplify because there are so many things we can do here. For example, what is square root of 100? 10. So see, we can easily look at this one, it's 10. We can do the same thing for negative 36 under the square root and negative 49 under the square root. Since we have a negative under the square root, are we going to get a real number back or imaginary number back? Which one? Of course, imaginary number. So what do you get from here? -6i, not -6i. So we have square root of -1 and square root of 36, right? Actually, let me write this one. This is same as -1 times 36. That gives us -36. True, right? -1 times 36 is -36. Now, exponent rule says we are allowed to distribute our powers. So we have -1 with the square root power and 36 with the square root power. If you convert square root, what power it becomes? Square root of x is? No. X to the power? 1/2. Radicule is a fraction, okay? That's why I'm saying you can split the power because radicule is a power, it's 1/2 power. But anyway, so what is square root of -1? Square root of -1 gives us what? 1i. And do you know what is square root of 36? It's 6.
-1, that's to make it positive.
No, what is -36? Which two number when you multiply, you can write -36. Every negative number, you can multiply -1 with the positive number, it becomes negative number. For example, -2 is -1 times 2. -4 is -1 times 4. So we have -36, it means -1 times positive 36. And we know what is square root of positive 36, it's just the number 6. And we also know what is square root of -1, it's the imaginary number I. So combining them, we get 6i. In other words, square root of -36 is simply 6i. It's 6, but imaginary. This is what it means. So if you follow this one, we have 2, but how much you get from here? 7i. We already know now, we don't have to show all the details because we already figured out from the first time. If you have a negative under the root, it's the real number times the I. That means combining all of them, what do we have if you multiply these two? 14i. And we bring down our extra -10. So do we have any like terms here at the end?
Yes.
The i's. So how many i's we have? 20. 6 and 14, right?
Yeah.
So 20i minus 10. The answer is correct, but the format is wrong. So we write -10 first, and then the 20i.
Why do we do that?
The format for our name is last name, comma, first name, right? In official document, last name, comma, first name. In official document, the complex number has a format, real number first, and then the imaginary number. So in informal place, this exercise is okay. Informal, no problem. But in a formal area, this is the format. You must write the real number first, and then the imaginary number. Good news, they actually don't put this question in the exam, in the final exam. So I'm not sure whether I'll put this or not. But definitely we have one division of the i's, reduce the power of I in the exam and also in the final. And with this, we are done at 10.7. And in our class, we did 10.6, right? We finished 10.6. Okay, so let's do one from here. Which one do you think we should do? A or B? A? Okay. So we have 2x minus 1 minus x minus 2. And yep, Stephanie remembered correctly. We cannot do anything until we make it weak. Now it has its friends next to that, minus x. So it can't do anything. So how can you get rid of the friends? What do you do?
Plus x.
Plus x. So we get 2x minus 1, x plus 2. And now ridicule is alone. And it's very weak. So what do you do? We apply the power to fight with it. So they fight with one another and they will die. we get 2x minus 1 left. But what happens to the other side? Good, you remember that. We never distribute power when you add or subtract. We cannot. Instead, we have to use FOIL. So would you like to try, Angel? Matthew?
Sure.
Exactly, thank you. Well, thank you, Matthew. So go ahead, Angel.
With the first x squared,
Mm-hmm,
then it x
mm-hmm,
and negative 2x again.
mm-hmm,
X,
mm-hmm.
and negative 2 times negative 2 is going to be positive 4.
Perfect.
And we combine my terms in the middle, so
Mm-hmm.
then it goes negative 4x.
Negative 4x plus 4.
Right.
And we had 2x minus 1 on the other side. And now we have so many x's floating around everywhere. So what do you do? Do you remember?
Put 2x minus 1 on underneath.
We move
Yeah.
2x and 1. So we have, what is left on the left side?
0.
And now what do you have on the other side?
Then that gives us x squared
Mm-hmm,
minus 6x
mm-hmm,
plus 5.
that's fine.
And then we can factor it out by recessification. So it's x minus 1, x minus 5.
The two numbers multiply to 5, combine to 6. Multiply to 5, but combine to 6. 5 has only two choices, 5 and 1. So it's definitely 5 and 1. But we have our middle term negative. That means our 5 must be negative. That's the rule. The bigger factor always gets the middle sign. So since we know 5 must be negative, that means to get negative 6, we must have to have our 1 negative. So negative 5 minus 1 gives us negative 6. That's how we have negative 1 also. So bigger factor sign is determined already. The sign for the smaller factor, we have to decide which one makes sense, positive or negative. So what do we do next? Gavin, go ahead. X minus 5, 0, x minus 1, 0. That gives us x equals?
5.
And x equals? Okay, so if you see this in the multiple choice, do you go and pick the multiple choice?
No.
You must check. So in the final exam, they actually trick you. They give you both answers so that you can pick, and so that I can give you 0. Right? So that's why just because you see them, don't pick them. First you check. Do they actually work? Do they really work? 2x minus 1 minus x is supposed to have negative 2. And since I'm taking it twice, so I'm going to write it twice. So in the exam, I will give you multiple choice. This question is multiple choice. So if you must show the work and then pick the correct multiple choice. If you show the work but pick the wrong multiple choice, it's 0.
The answer.
We have to see. First, you have to check. First x is 5. So 2 times 5 minus 1 minus 5. What do we have inside the radical? 10 minus 1. And what is 10 minus 1? And what is square root of 9? And what is 3 minus 5? So do you get what is supposed to have? Yay! So this is correct.
So if we see 3 minus 5 equals -2 on the multiple choice, and that's the.
No, you must take both of them. Sometimes none of them work. Sometimes both of them works.
But I'm saying if 3 minus 5 equals 2, will that be on the multiple choice?
No, multiple choice, Let me give you what will be the multiple choice. So answer choices. First of all, you're going to see both of them. 5 and 1. B will be x equals only 5. C will be x equals only 1. D will be none. D any. Not D any, no solution actually. No solution.
Oh, so that's what.
So just because you see both of them, it doesn't mean you go and pick the A right away. And just because you see x equals 5 works, it means answer is B. No. We also have to check C. So this time our x is 1. So 2 times 1 minus 1, we subtract 1. We're supposed to get the answer -2. So what do we have inside the radical? 2 minus 1. What is 2 minus 1?
1.
And what is square root of 1?
1.
What is 1 minus 1?
0.
Do you have the same thing?
No.
So this one doesn't work. So our correct multiple choice is x equals 5. So you show the work and then you pick the correct choice. Only then you get full credit, otherwise it's 0 credit. If you guess it, no. Or if you plug in and then check which one works, no. The work must be shown, okay? You cannot check without doing the work. And one of them definitely will be in the exam as well as in the final exam. Any question on this? We don't have time.
Yeah.
I asked the department because student did that. And I was like, well, actually they did check the answer. They said, well, they did not show the work. So they want to see, do you know how to solve this? So you have to show them, yes, we know. This is a solving process.
On the exam, you'll give us scrap paper, right? To
Mhm.
show our work. Okay.
Oh man, what happened? Okay, now rationalizing the denominator. It means we are trying to divide by a radical, but it's not possible. We don't know how to divide by a radical. And I actually sometimes wonder why mathematicians didn't know how to divide by a radical. Why? What is so hard? Why can't we divide it just like normal division? I don't know. We don't know how to divide by radical, so we do rationalization. So let's say we are doing E. 2/3 plus square root of 7. Rationalize. Anytime you see the word rationalize, it means you have to use what? We have to multiply by what? Conjugate. So what's the conjugate of the denominator? 3 minus 20%. Now, Parker, what do we have when you divide the denominator? Sorry, when you multiply the denominator? Three square minus square root of 7 square. That gives us what? 9 minus?
7.
And what is 9 minus 7?
2.
That's why I said, if you have one single thing on the numerator, don't distribute here, okay? Don't I don't have space. Don't distribute the top. So we keep 3 minus square root of 7, 2 times 3 minus square root of 7, 2 times 3 square root of 7. Why I did not distribute the top? What do you notice now? You see? We can cancel these two with the other two. And you must reduce always. So since you have to reduce at the end anyway, why wasting our energy by distributing on the top? Thus, I don't distribute the top if you have a single number on the top. But if you have two terms on the top, then you must distribute. For a single top, keep it. It's a single. We don't bother with it. Keep it, keep it, keep it. Any question? So one of them will be in the exam. And probably one or two from the multiplication. Can you guys read the small letters? No, right? By looking at it, which one you think I should go over? A, B, C? Just by looking at it, it's like, which one seems, even though you cannot read anything, which one seems A? Okay. 4 square root of 2 plus 7. 3 square root of 2 minus 4. So what do we do? Distribute. So what do we get? We have 4 square root of 2. We are multiplying 3 square root of 2. Matthew, would you like to give me the next terms when you distribute? The left page. Are you done with the right page? I'm saying, would you like to help me solving the left page? It's 12, but how many times you see the root 2? It's root 2 square. That cancel out. We multiply, we get 24. So that's the first term. But you're not done, right? We have 3 more terms to go. Try the next one. So from here we get negative 16. But we're not done. We have negative 16. 4 times 4. What happens with the square root of 2?
Bring it down.
Yes,
See? You must bring it down. Okay, now the other way around. Cassandra, would you like to help me with the other way? Plus. 7 has a plus sign in the front. And 3 times root 2 also has a 3 root 2 also has a plus in the middle, right? Our 7 has a plus sign. And this one also has a plus sign. So when you multiply them, it's supposed to have a plus, not minus. It's a minus value. Yeah. It is plus. Plus 21 square root of 2. And finally, plus 7 times negative 4, that gives us negative 28. Okay, now what happens? Anji. Plus 5 square root of 2. And we just K down that 21 is extra. And now what happens? Zihong. What happens next? So I combine these two, we get -4 plus square root of 2. And now we are done. We collected all the whole numbers together and all the radicals together. So here the main thing you should remember is this square. When you multiply square root of 2, square root of 2, you get square root of 2 with a square. Or you can write square root of 4 and the square root of 4 becomes 2. But square root of 2 square is better because sometimes they give big number. Okay, square root of 29. 4 square root of 29 times 3 square root of 29. If you try to multiply 29 times 29 and figure out what the square root of that, you'll be done. Any question on this? No. Reducing, simplifying radical, multiply and simplify. I'll do only one of them. Let me do this one because this one is harder. Cube root of 3 is part of cube root of 3x to the 7 times cube root of 18x to the 9. When you multiply, we get two things. 3 times 18 together and the variable x to the 7, x to the 9 together. 3 is 1 times 3, but we are looking for same number 3 times. So you have two choices, either break down 18 into 2 pieces or break down 18 into 3 pieces. It's up to you. So if you break down 18 into 3 pieces, which 3 numbers when you multiply, they will give you 18. Okay, so you want to use 18 is 6 and 3. So 3 we cannot break down any longer. How about 6? 3 times 3 is 9. 3 and 2. That means 3 numbers we multiply becomes and give us 18 is 3 times 3 times 2. We are looking for same number 3 times. So we already see that. We see 3 times. Julia? You can also write 9 times 2, and then you can split 9 into 3 pieces, 3 and 3. So we split our number radical into 2 pieces. One with the things we see 3 times, and one is whatever doesn't have 3 repetition. So 3 cube, we get 3 3s, we write as a cube, and the 2 is alone. So we put it back inside our radical. 3 power 3 root cancel out. We get 3 free. It's floating around everywhere. But 2 is inside the house, the cube house. For variable, what do you do with the powers? Add, divide, multiply, add. So what is 7 and 9? 16. And then we see how many times we have 3 in 16. So 3 goes to 16 how many times? 5 with a remainder 1. Because we have a remainder, that means we are gonna write excess twice. One of the whole number power will go outside the radical as a power. The remainder will go back inside the radical as a power. Cube root of x with a power 1. But we don't have to write 1. I'm just writing to remind you that whatever remainder we have, It goes back inside the radical as a power. So we divide, whole number goes outside, the remainder goes inside. Now what do you do? So when you combine, what do you combine? 3x to the free, they are free. We'll let them play together. And inside the house, what do we have? 2x. These are our final answer. Any question on this? What's to be here? 6x to the negative 3 with the negative 2. 2x to the negative 2 with the positive 3. So our goal is to simplify everything here. Do you remember what is our first step? What do you do, Stephanie? We distribute the power to everything. So on the top, we have 6, x to the negative 3. On the bottom, we have 2, x to the negative 2. The numerator has a power negative 2, but the denominator has a power positive 2. This is small one. And do you remember what did I tell you about the number with a negative power? So don't touch until you convert this into a positive power. So for now, let's keep it. I'm going to change that into a positive later. But what happens when you have double powers? Do you multiply, do you add? So negative 3 times negative 2. 6. And this one doesn't give us any problem. It's simple. What is 2 squared? 4. But here we have double powers. So what it becomes? Negative 4. And now 2 things doesn't give us any problem. 2 things gives us a problem. We don't like this because it has a negative power. We don't like this because it has a negative power. So what do you do now? We move their position. So on the top, we have x to the 6. And now we are moving x to the 4 so that the negative 4 turns into a positive 4. On the denominator, we have 4, but now we are moving the 6 squared from the top so that it becomes a positive 2 instead of a negative 2. Any questions so far? Okay, now what rule we have for this?
Adding exponents.
We add. So what do you have x to the? 10. And on the bottom we have 4 times 36. So what is 4 times 36? We need to do it manually. 36 times 4. 24, so 4 goes down, 2 goes on the top as an addition.
Then we add 12 to plus 2. That would give us 14.
So this is our final answer. X to the 10 on the top, 144 on the bottom. All of these are final exam questions. So you'll see them again in your in-course exam. Any question? Okay. From here, anything? let's do the easy one first. Negative square root of 16 to the power 1/2. Square root of negative 16. And what is square root of negative 16?
4i.
It's 4i. Square root of negative 1 is square root of positive 16. That gives us I from the first one, 4 from the second one. So it's 4i. How about 16 with the negative 3/2 power? Do we remember what do we do in this case? What is our goal here? What is your denominator? So you're looking for what? Same number how many times? Twice. So what number square gives us 16? 4. So every time we look at the denominator, we rewrite our number in terms of the denominator, because our goal is to cancel the denominator with the new power we get. So plus 2, minus 2 cancel out. We left with what? And how do you convert negative 3 power into positive 3? It becomes a fraction, 1/4 to the positive 3. But what is 4 to the positive 3? 64. You don't have to memorize, you can multiply them. 4 times 4 is 16, and then multiply 16 times 4, you get 64. They all will be in the first exam. What's the difference between these two? If you have negative 4 square and negative 4 whole thing squared, what is negative 4 squared? Are they same or you're going to get different answers?
Different answers.
How different the answer we get? How do you know which one is what? Good. First one doesn't have any parentheses. That means our negative is extra. No parentheses means negative extra, carry it down. So it's negative 16, but this one has a parenthesis around. Positive answer. We'll definitely see them tomorrow. Okay? Not tomorrow, I mean next class. First exam.
No, so for any given x1, there is no
No. If you have a negative in the parentheses with an even or even power, you said. Yes.
Yeah, it's a power, yeah.
Right. I was thinking about even denominator. Okay, then I'm going to give you this one also. Okay. So we have f of x is x squared minus 2. And they want us to find f of 4 plus h minus f of 4. So let's find f of 4 plus h first. So we keep our structure same, but the x turns into 4 plus h. Well, good, you remember that. So 4 plus h times 4 plus h, and then you subtract 2. If you use FOIL, you'll see that it becomes 16 plus 8h plus h squared. Do we have any like terms to combine? So we get 14 plus 8h plus h squared. And now next, they want us to find f of 4. So you keep our structure same, something square minus 2, that something turn into 4. What is 4 squared? And 16 minus 2? 14. So this is the first part. Oops. Actually, let me use different. So this is part 1. And this is part 2. Oops. And now they want us to combine them. F of 4 plus 8 minus f of 4. So f of 4, we found it's 14. So subtracting 14. But the first one we found is a big thingy. Ah. So this big thingy is 14 plus 8 plus 8 squared. Right? So when you combine them, what happens? 14 cancel out. So this is our answer. 8 plus 8 squared. Or 8 squared plus 8. This is the finalizer question. So we'll see this again, probably in your final. Do you remember your transformation? Kind of. Okay, let's do one example. Can I flip my page? Can I? Okay. So we have 3 types of transformation. Let's review them and then we do the next one. The first one says negative x minus 2 plus 3. Which type of graph we have for this type of function? It's a V. So original graph, oh, I should draw it bigger. Original graph is a V, square root of V. Now we have a negative in the front. What does that mean?
The reflection.
Upside down V. And we have a minus 2 inside the radical. Not radical, it's a left or right, which one?
Right.
Right. For inside, it's opposite. So it should be right 2. But outside is same. No, outside gives us what direction? Up. See. Outside means up, down. Inside means left, right. So the same V, we are making it upside down, and we are moving 1 right, 2 right, 1 up, 2 up, 3 up here. And we are drawing the new upside down parabola. Not parabola, V. Negative x minus 2 plus 3. One more, and then we are going to do the next one. We have negative x plus 2 under the square root minus 3. So, which type of function we are dealing here? Square root. What is the shape of the square root function? It starts from 0 and go upward, but slowly. This is the normal one without any transformation. Now this transformation, we are doing what? A reflection, so it goes downward. And then plus 2 inside. Left 2. Minus 3 outside. Down 3. So we are reflecting it. And this reflection, we are moving 1 left, 2 left, 1 down, 2 down, 3 down here. And these are new one. Negative x plus 2 minus 3. So in the exam, make sure you draw the original one. The original one is 1 point. And make sure you show me you're working, okay? Here I walked 2 left, 3 down. Say I showed you the step, and that on the other one we walked 2 right, 3 up. So make sure you show me your steps. If you show me your steps, you'll be fine. You get at least some point for your steps. And then for correct shape, you get the whole point, full point. So 3 points in the reflection, 1 point in the original one. Any question?
Wait, can we do the point?
You're losing 1 point because for original one is 1 point.
So you're saying that if we show something like this on the right page, that means we get full credit?
Okay, now using this cubic function, the graph is given, figure out the transformation. Let's say this one. And this is our axis. So what is the shape? What is the function of this shape? What is the function for this one? This is positive x cubed.
Oh, that's the original one.
So that means what is this function? Negative x cubed. And now this negative x cubed is moving here. So what's the new function?
X plus 2 outside.
Plus 2 outside because you moved upward. Upward means that the number is after you cube. But how about this one? You have 1, 2, 3, 4. So y is, and this is our original one, right?
X cubed plus.
Almost correct. This -4 must be inside your cube. So x minus 4 and then the cube. If you write x cubed minus 4, it means the x cubed graph went 4 units down, which is wrong. It's x cubed graph went 4 units to the left, so 4 units to the right.
If that one were flipped, do we put the negative sign outside the parentheses?
If you had, so let me actually give you one which will be in the exam. Something like this one. Let's say 1, 2, 1, 2, 3. So what is the equation for this one?
The negative parentheses x plus 2 close parentheses plus 3.
Your left right should be inside your cube. The plus 2, is it inside the cube? So mistake, this should be up here. So x plus 2 inside, and then the cube, and then the extra t. So it's plus 2 because you want 2 left. And it's plus 3 because you want up 3. So we did transformation. Let's do one more. We have this function and they want us to find g of 5. What is this 5? X value or the y value? So they gave us x is 5. We want to give them what is y. When x is 5, what's the y value we have? 3. So the answer is simple 3. But on the other hand, they want us to find what is g of x equals 3. Find all x values for which g of x is 3. What is this 3? Y. So y is 3. When y is 3, you should draw a line. How many points you see in the graph for same y? 2. And they want us to give us both of them. What's the first one?
Positive 5.
And positive 5. See? When y is given, draw a line because you have more than 1 point. But when you're looking for x, it's simply the y value. Okay, so in my morning class, I actually went about one here. I went about probably slope, I don't remember. I went about this, and I went about this, And this, oh, also let me tell you what will be in the exam, okay? So I'll send you my morning link. Whatever we didn't do here, you may find them in my morning class.
You upload these to YouTube.
Yeah.
And we can use the review sheet, to practice, right?
You must. Okay, so in the exam, I'll give you this, probably 6 or 7 graphs. Also this, probably 2 to 3 of them. From here,
Exactly this will be?
Huh?
Like, or the numbers will be different?
of course different. I'll give you similar question. So number 1, you'll definitely see. Number 2, you'll definitely see. From number 3, we did very same one just now. So one of these. From here, I'm going to give one here. Actually, let me be honest. I'll give you something like this and something like that. 2 of them. And I don't remember how many, but 2 or 3 of these. Find the domain and range. 2 or 3. Find the slope, definitely 1 from here. Slope, x-intercept, y-intercept, something like this one. Parallel or perpendicular line, I'm not going to give you the simple one. I'm going to just ask you with a question. Find the perpendicular line or find the parallel line, blah, blah, blah. This, we just did this one. 1 from here, we don't know which one. Is it V, or is it square root, or is it cube? But definitely 1 from here. The graph will be given, you have to state their transformation. Definitely distinguish between these 2. 1 from here, 1 from there, 1 from here. By the way, in my review sheet, which I posted on Blackboard, I actually missed this part, but we'll have 1 from here, okay? And 1 from here. We went over this today. 1 of these, 1 from here. Not sure both of them or 1 from multiplication or division. Okay, not sure whether I have number 9 or not. But if you do number 10, you're doing number 9 anyway. So I'm not sure. Definitely 2 of these. Around 21. Plus all of these.
Is this like extra credit?
No. They're not extra credit. They are 1 point each. So you're going to do probably 30 of them. Because we have 30 different scenarios, kind of like. Okay? So easy 30 points if you know your rules, and then math portion. In the math portion, some of them will be multiple choice, no partial credit. The rest will be non-multiple choice, but you'll get partial credit for your steps. Okay? So good luck, everyone.
Yeah.
And are you going to come online tomorrow? Okay, I'll send you an email.
Well, you have the answer key online. See if you got.
All of them are from our lecture notes.
Okay.
So if you have your lecture notes, you can find them there. If you don't, I recorded every lectures, so you just have to go through the lectures.
Okay. Also, will we be able to?
Yeah.
Okay.
Thank you.
Run down to the second floor. Go there and
I don't need extra time. I'm gonna take it in class. No problem.
Christmas.
I'm gonna take it in class.
You sure?
Yeah, I don't need it. I just have use for a calculator. The simple one.
Are you sure you don't need extra time?
No, I don't.
You definitely sure?
Yeah, I promise you. I've taken this math in high school. I'm 100% good. I'm fine.